you guys are done taking the survey, go ahead and write down what I'm writing down. Okay, so this is going to be your first warm-up. Be very careful too. I don't know if you guys can read that, but be very, very careful of the directions here. There are differences in each of these problems. I'm expecting you to do to A, B, and C. I do not expect anyone to be able to do D. D will be a very challenging problem because you theoretically have not seen this yet, if this is your first time being exposed to this. And Katrina and Natalie, did you guys want to make any more announcements before I just launch in a lecture or anything? Or you just need to take the exam, or have the students take the exam? Yeah, okay. I didn't know if I was, in the middle of your scientific process or something. So, I don't know. Okay. Okay, so if you guys can see that, you guys have time, or if you guys are done with that quiz and you've already given it back to Katrina and Natalie, then go ahead and start on this warm-up or write this down in your paper. But ideally, I want you to do this warm-up on the whiteboard, meaning grab some erasers and a dry erase marker and then erase anything on that whiteboard right now. And if you don't have a whiteboard, you can grab one from anywhere in the room. Like there's one in this corner here. There's one actually, interestingly enough, behind Katrina. You guys can grab whatever you want. And sorry, Katrina and Natalie, you guys are free to sit down or just relax or whatever you'd like. Okay. And then Greta, I need to get some stuff for you. Go ahead. All right, guys, get to it. Don't be afraid to use your phones or something if you don't remember how to do this, okay? Use any resource you can to call back what you do for this problem. Stephanie, actually, everybody can see that, right? Okay, good. All right. Go ahead and continue. Sean, please come here. Here's this for you. Stay here for 1 second. I think I have your exam. I don't think I know I have your exam. Greta, please come up here after you're finished with that assessment. Here you are, sir. Greta. You are on. You're not finished with me. Okay. You have this. Okay. All right. Thank you very much. And Greta, put your hands through the paper. See if usually I attach someone else's stuff by accident. No. You know what I mean? Like I kind of sticky hands. Like, okay. Best of luck. Try to figure this out. If you guys can't see, you guys can knock down both the lights if you guys want. Thanks, Stephanie. Yeah, that works. Okay, so this is your challenge. Try to find out F inverse. So the inverse function of x. What do you have to do with that? Wait, are you doing that one? Okay, inverse. Anybody stuck? You guys, this is pretty tough, I think. Not easy to recall. You guys are good? Oh, we have you. Have you guys about 1 more minute? Or 2 more minutes? I'll give you guys 2 more minutes. Oh. Where is that? Yeah. All right, guys. I'm gonna stop you guys. So go ahead and have a seat. Look at your solutions, and then I'm gonna kind of go over them really quick. Can anybody tell me the difference though between number A, what I'm asking for number A, and what I'm asking for number C? Any differences between A and C in what I'm actually asking for?
A is the inverse and C is the derivative.
Okay, so they are entirely different things that I'm asking for. Okay. So the inverse function. Anybody besides Stephanie, does anybody have anything to add to how did you begin this equation, or how did you begin solving for this problem? So what did you do, Sarah? Yeah. Nothing. All right. Okay. Okay. I know you did things, but you're just being modest. Okay. So I guess I'll kind of go over it then. You can look at it as you can rewrite the function, the f of x function, as y is equal to c. You do want to write this down in your notes, okay? So write down either your solutions or my solutions to see if you got it right onto your notes, because this d ultimately is something that you shouldn't really be aware how to do quite yet, unless you kind of started the homework and you have a good clue about what to do. Okay, I'll give you a clue. D, you should have gotten 1/3. So if you did not get 1/3, you did not do it correctly. But that means you just didn't know exactly what I was looking for. Okay, so let's anticipate that there's going to be new content in D. A, however, let's set up again. Let's write this as y is equal to x to the third power minus 1. You have a few options for what you can do. So to find the inverse, that's not formal notation. That's just kind of my way of saying I'm going to invert this, and I'm going to switch the placements of the variables. X equals y to the third power minus 1. And the technique here is to solve for y in this state. And then ideally, through this process, I will find the inverse function. You didn't have to do that. Some people solve for x and then solve and then switch the variables up. At some point, you want to switch the variables up though, okay, in the placements that they're currently in. So I like to get kind of just do that right away. Then I solve for y in this state, so I add 1 to both sides. Sorry, this is a 1, and I have x plus 1 is equal to y to the third power. How do I get rid of that that cubic exponent of y?
Cubic root.
Yeah, I take the cube root basically of both sides. If I want to make this equality statement still substantial and strong. So what I currently have is x plus 1 cube root is equal to y. That is my solution for A. B, I asked you to solve for the function at 1. So what does this mean I plug 1 into? Where do I plug 1 into? Yeah, the original function. I didn't ask you to take the inverse of when x is equal to 1. So that means I plug in 1 into the original equation. So f of 1, so let's write that down. F of 1 just means 1 cubed minus 1. That is going to give me 0. I also asked you to take the inverse now, the inverse function of 0. Before I do this, does anybody have any hypotheses or theories on what the answer is going to be if I plug this in? Any guesses here as to what it's going to come out to be? Okay, all right, let's see. I'm going to say it right, but yes. Okay, so let's see. You take the cube root, so we plug in 0 in place of where the exponent was from our last equation. Or not the exponent, I'm sorry, the variable, which was x. This is going to be 0 plus 1. And you take the cube root of that, and that is going to give me the cube root of 1. And as tough as that looks, the answer is just going to be 1. Any weirdness, any weird occurrence that you have observed from B when doing B? What did you notice about these two answers? Yeah, Sarah.
The points are like inverse, like if
Mhm.
the f function is 1, like 1, 0,
Yes.
and then the inverse of that function is 0, 1.
Yeah, that's really good. This phenomena is sort of looked at as if you have a coordinate that's like b comma a in the original function, what that would translate to in the inverse function would be a comma b. It would just kind of switch fully around. Okay, that's kind of the purpose for why you did it this way. That's what we call the inverse function. If you switch up the positions of the x and y, and then you solve for that y, that technique, you'd come up with an equation where all your coordinates are sort of inverted, or the inverse of each other. Okay, BA is now switched with AB. Please kind of get used to that notation, BA and AB. I'm going to come back and revisit that. Okay. And then C, I think I asked you to do, what is it? The derivative of 0, I think. The derivative, 1. I'm sorry about that. Oh, did I? Let's see. Wait. Yeah, that's correct. Yeah, that's what I wanted you to do. Yeah, sorry. I was fixing up my notes from earlier today. So, well, before we do that, what must we do before we solve for the derivative at x equals 1? Yeah, so it would help to kind of figure out what the derivative, the general function, even looks like. So if I have my original function as x to the third power minus 1, what is the derivative of that statement going to be? What's the derivative of x to the third power? So yeah, it'd be 3x squared. And then what's the derivative of any constant too? Like minus 1. That minus 1 part right here. The derivative of any constant should be 0. Yeah, so that's it. And then now if I plug in 1, I just plug in 1 to that equation. Squared, that's just going to be 3. The final step is something you may not know yet. Wow, so some of you guys actually got one. Okay, so how did you guys find out over there on which Brendan Black? Did you guys get that too? I'm so sorry about that if I discounted you guys. I haven't looked at your work because it's on flat on the table. Okay, how did you guys get that it was 1/3? And
I just did the
how would you describe that though? A relationship between C and D. Like, what is the relationship between? Yeah, it's sort of the reciprocal, but let's see how you should get that. So the whole thing, it's fine. I mean, you just know it, and ultimately on the AP exam, that's our goal at the end of the year, right? You're doing it for speed, right? Quality first, but speed if you can afford it second. So let me show you what you are supposed to do. So let's, how would you find the derivatives? So this is where we get, not only is it your warm-up, but this is launching into the new content. So write this down as your note. How to find the derivatives of inverse functions. There are two ways I'm going to kind of show you how to do this. They're both the exact same way if you really think into it. They're just presented in two different ways. So here's the first way. This is the more cordial, formal way to learn this, right? if you have a inverse function written as such, and you take the derivative, okay, so that kind of like that symbol means prime, meaning you're taking the derivative of this function with respect to x. This is the way you write with respect to x here when you're not doing dy over dx. Here's what the formula will end up looking like. It'll be 1 over, bear with me, yes. This is going to be 1 over the derivative of the function. It's going to be a composite function. Not going to be easy, right? So for the first time you're going to be exposed to this. It's the derivative of the function, and if the input value is not x, it'd be the inverse function of x. Wrap that around your brain. How the heck is this going to happen? So if you want, you can box it, square it, something, make a highlight somehow, or kind of, I don't know, write something in your note that kind of like, hey, look over here. Like at all your notes, this is probably like the new stuff that you might want to kind of just learn from. Or you don't have to do anything. Some people just don't need fancy notes. They can just look through it dry as bone. Okay. How to find the derivatives of the inverse function. So what's that going to look like? Well, let's just plug in what we have so far. I asked you to take the derivative of the inverse function of, let's say, what is it? What was it? What was the question actually? 0, right? Of 0. What that would amount to is to find the derivative of the inverse function of 0. That looks really tough. But look through your work here. Did we not already solve for the inverse function of 0? What? Where do you see that though? Okay, yeah, and not only that, we did the work for it here, right? If I can kind of show you the laser here, we did the work for it already. The inverse function of 0, we've already solved for. We've already plugged in 0. We put it into the equation. It's 1. So in place of what this fanciness over here that's kind of going on, I literally just put in 1. 1 over. Hold on though. It's text. Don't get rid of this guy. I mean, the only guy I'm really substituting is the inverse function of 0. This outside kind of not junk, but like kind of like extra kind of notation is still going to be there. It's f prime of 1. What is the f prime of 1? Again, look through your work. Did we not already solve for the f prime of 1? Yeah. Where do you see that? C. Okay, that's a kind of a weird pun in itself, or I don't know how to describe what that phenomenon was, but C, yes. C, yes, for C, yes. Okay, that is just 3. So you literally just put in 1 over 3. And ultimately, the last thing is, what is the relationship between the derivative of, or did I want to say that? Yeah, between, the derivative of 1 and the inverse derivative of 0. What do you guys notice about the derivative values? What do you call that when you have two numbers that look very alike, but if you write that as a fraction, 3 over 1, and the other value is 1 over 3, what would you call that phenomenon between, or what would you call the relationship between those two numbers, where it sort of flips in its fraction value? We call it the reciprocal. So, and here's another relationship that you might not see as well. If you look at it here, the coordinate for the function was 1, 0, right? Its inverse coordinate. So I'm going to call this, if you can go back to this and write a note, I'm going to kind of name this. I don't think they actually name it this way, but I call it the inverse coordinates. I call these guys inverse coordinates. 1, comma 0, and then the other one was 0, comma 1. Or to generally speak, it'd be b, comma a, or a, comma b. Those would be your inverse coordinates. If you're taking the derivative of one inverse coordinate, and you take the inverse derivative of the other inverse coordinate, what you would expect to see is that the derivative values for that, or the slope values at that point, are going to be flipped. They're going to be reciprocal values. Okay, so that's the ultimate phenomena I want you to kind of experience and see firsthand. Okay, this is very tricky. It's not hard. It's just super tricky to trick your brain to thinking. It's like it becomes intuitive. It's like at the edge of being intuitive to just I can't get this. Like I'm never gonna get this. Okay, so for some people it's like I don't know. It's like a tongue twister. You just get it or you just don't. I don't get it. So like a lot of times I have a lot of trouble explaining this concept because I trick myself into not understanding it. So I'm gonna give you one more problem just for kind of like practice. All right, it's gonna be the same thing. So do I have? Where is it? Okay, so here's gonna be the same thing, the same setup. F of x is gonna be 3x minus 1. Your book's going to write it like this, okay? G of x is going to be equal to the inverse function of x. Why is it like that? Why is it written like that? Well, they're going to present to you, they add that one more layer of complexity, okay? They're going to ask you to find g of x, which basically is asking for you to solve for the inverse function of x. Then I want you to find, let's see, what is it? Find f of, f of 1 and g of 2. C is a, what is it? Find a f prime of 1. D is find g prime of 2. And then E, what is the relationship between C and D? See if they are actually inverse functions. I don't know. Okay, guys. More whiteboard time. This is not going to go in your notes, this part, unless you want it to, this example problem, okay? If you like it to, then you may. It might actually help to have 2 examples on your notes. But solve for this. Try to solve for this. Instead of going through this one on the back on the, what is it, the camera, I'm just gonna go around and check your answers and see. Dr. Kaluzhny, come on over here. I have your exam. Sorry, if you're wondering what this is, this is a whiteout pen. I just draw stuff sometimes. So, yeah, in case you're like, right here. Yeah, no problem. I think also I have graded work in here. I'm not sure, maybe I don't. Kind of take a look. So it's very okay, just making sure. Hey, you guys are. I'm gonna go around if you want to check your answers. Go ahead. Incorrect. Okay. Where'd you find that? Okay. All right, I'm gonna go around. You guys want to check your answers? Okay. All right, so go ahead and have a seat. I think most of you guys are getting this. I took the liberty of graphing those two functions. So in red is your original f of x. In blue is what you should have gotten for your inverse function. So at 2, 1, so when you solve for b, you solve for the function of, I think, 1. So you got the output value should have been 2, right? So this should be 1, 2, I'm sorry, 1, 2 on the original red function. That's f of x. The inverse function at 2, can anybody guess what the coordinate is going to be at the x value of 2 of this graph here? Yeah, it's 1. Can you give me the slope at that point, that individual point right there? What is the slope at that point? You actually solved for it. Maybe you didn't realize it. Let's go back in your work. What is the slope at that point, or the derivative at that point? Which letter problem was that you just saw for? A, B, C, D, or E? Yeah, on D, you guys actually solved for the derivative of. So in blue is the g of x. I'm sorry. So we called it the g of x, but we know that to be just the inverse function of this guy up here. Okay. So the g of x right here, when you took the derivative, the g prime of x, you solve for the slope at that point. That should theoretically be 1 over 3. What about the slope at this guy up here? 3. Trivia question, what is the slope of this guy here?
3.
How do you know that?
Because the slope's constant. It's a line.
If it's a straight line and there's no curves or bumps to it, the slope is consistent. It's constant. So that's just a little trivia there. How about over here? What if I took the derivative at -4? What is the slope of this guy at negative? It's still going to be 1/3. Okay, so extra trivia there. Last question. You guys found out that, what do we call this if the slope is almost looking like the inverse of this slope here? What do we call that? Sorry, what's the term for that? That's all I'm asking. Yeah, they're called reciprocals. Don't be confused with when you take the negative reciprocal. That's literally adding a negative to your reciprocal value. So if I ask for the negative reciprocal of the slope of 3, that would not be 1 over 3, but that would be negative 1 over 3. Okay? Reciprocal itself is just flipping the fraction value, right? Okay. The weird worksheet I gave you on your cover sheet, not today, don't worry, I didn't give it to you as a handout, but the weird kind of worksheet I gave you for the cover sheet for this month. If you don't know what I'm talking about, I'm gonna kind of pull it up really quick. Gotta be very careful. This might crash the video. I'm learning that if you add more apps to this right now, and you're like making the computer do more things while we're recording, this is the application right now. My mouse pointer is on. That's the mouse, or that's the application that's recording what's on my desktop. It might crash the video. I don't want that to happen. So I gotta be really slow when I do stuff, even when I scroll. And these videos I recorded last year, what we're talking about right now, but I don't think it was done quite as smooth. Yeah, let me pull this up right now. So, in case you did not start the homework, it will be a tad frustrating, and I do apologize, because it's not from the book. In fact, I think there was no section that had inverse functions or derivatives. I think they had what we call the integrals of the inverse functions, but they don't have the derivatives. So what I did was I gave you a supplemental sheet, where you click on the link here. This link is exactly the same as this link, so I just wanted to be redundant. I only asked that you do problems 1 through 10 on there. I'm about to go over like 2 more problems from that. And then anything else that you want to do is optional. The main reason why is because there's no solutions manual to this. Okay, so, but kind of what we're going through there, it's sort of like its own check and balance. These problems are set up kind of like what Reese, I overheard you saying. Some of these problems are, or most of these problems are pretty much set up to where if you solve for one thing, like the other answer should either be an inverse coordinate or reciprocal value for the derivative. Okay, so that's kind of like in itself a check. Okay, but it can be frustrating. So come and see me if you're not really happy with that. I know Stevie came in to see me yesterday because some of the answers, since we didn't have a solutions manual, it's like, I don't know if I'm doing this right, Mr. Wee. Okay. We're going to go through 5.1. We're not going to go through together. I'm going to post up 2 videos that I found last night. I think I explain it a lot better than I would. And it's a little bit more concise. I would say that's about probably 10 to 15 minutes of your time in total. So I'm going to post up 2 videos for that. And then hopefully we will do 5.2. If we don't get through 5.2 today, I'm going to have to make a video on 5.2. Okay. And then 4 and 5, lines 4 and 5 is what we're going to go through next week. Ooh, whoops, I just changed that. I didn't mean that. Okay. And then You have your practice exam to work on, and then finally the third week we're going to take our month 4 exam. Okay. You guys have any questions so far? Is anybody happy with the fact that we still have a week of school after these 3 weeks? Is anybody aware that we still had a week of school after that? Yeah, right? Yeah, that was. I don't know. Yeah, but I'm glad I knew that before I started planning my vacations and stuff, or else I would have been gone. And I'm the teacher, and the teacher's not here. That looks weird. Okay. Yeah, I'm just overhearing your conversation right now, but yes, that is absolutely correct. What's up, Stephanie? I'm sorry, what did you say, Stephanie?
I think the schedule the extra week at the beginning of the year and
Oh, okay. And that's probably what screwed up the schedule, huh? All right, guys, if you guys can, draw this with me.
I did too until 2 days ago, and I'm really annoyed. That's how it always goes. We always have Thanksgiving. We always have a month. Month 3 always finishes right before Thanksgiving, and we have Thanksgiving break, and then we have month 4, which finishes right before the break. This year we decided to move up.
Let's mess this up. Shoot. Sorry, guys, I'm messing up my picture right now, but please copy down this picture if you guys can. Man, I'm not good at this. All right, guys. So hopefully you guys join this. No?
Right, but my friends who don't go to the school and go to other public schools, I might be able to see where I want at that time, but it's not like I'm.
All right, you guys don't mind anyway. Halt your conversation for a second. I know. Yeah. Well, like yourselves, I didn't learn about this until last week. I'm like, wait, what? Like we have another week? Because I was planning to go out of town, but I'm glad like I said, I didn't, or else the students, you guys would probably be a lot more responsible and be here. I wouldn't be here, so I understand. Please draw this if you haven't already. It's not good. I'm not good at doing this quite yet, but the axes I set to where you have the increment of A is equally spaced on the y-axis and the x-axis, and then B is a x value that also has the same kind of increment kind of distance from the origin on the y-axis over here. Then I drew a line that goes right, like a diagonal line that goes right through the middle of the axes. That's kind of like the boundary to make like the mirror in which you can kind of see if you drew a function, the other one would be the inverse function. And then I drew a coordinate right here at a comma b and b comma a. These are the inverse coordinates that lie on each of these functions. So this is kind of like a summation of what you're learning right now, of what inverse functions are. And you can kind of look at it as b, the coordinate b. If you go through the function, you put b into the function, like you take the f of b, you get a. Does that make sense? So again, if I put b through the function, the equation, of f of x, I get a as the output. Okay? If I went backwards, though, and I put a as the input, right? If I put a as the input, meaning like the x, right? It goes in place of x here, the coordinate, and I put it into this equation, it would spit out b. It would spit back out b. Okay? That's one way to look at this. What I'm trying to get at, though, is in your... Hey, Mr. Rohr, go ahead and just relax. Another way that your worksheet, the reason why I brought up that worksheet in the first place is they present this information like this. If you take the inverse function and you take the derivative, and let's say the derivative is a b value, and you know the coordinates. Let's say you actually know the coordinates already, a and b on f of x. Oh, I'm sorry, a and b on f inverse of x, and then ba on f of x, right? You could take a little shortcut. It's just essentially this. That's the way that your worksheet presents it, and it gives you puzzles according to this kind of nice, kind of stripped down version of what we just learned. It's exactly what you learned just now with a lot less notation. In some ways, a lot of you guys will train your brains to think this way instead of the other way. The formal way that we just went over was this, and it's saying the exact same thing. The inverse function, if you take the derivative of the inverse function of x, that would just be 1 over f prime of the inverse function of x. That sounds really confusing. So the worksheet thought it would be, or like the people that wrote that worksheet in the book that it came from, okay, wrote the equation to be memorized in this way, in this manner. It's a little bit easier. If you have a coordinate BA, so this is assuming that f, again, has a coordinate that is BA, right? You can write this as a reminder. The inverse coordinate would be AB. The equation would simply be stripped down as this. If you're trying to find the derivative of this coordinate here, you'd simply take your A coordinate and then plug it in, but you'd have to find the derivative of that and put it on the bottom. Does that make sense? Maybe it won't, okay, because I just kind of sped through that really quickly. But this is something I would hope that when you write down as a note, you're going to go home and kind of study over and be like, what happened, right? Look at it for about 20 minutes or so, let it try to sink in your brain. And hopefully my hope is somewhere along those 20 minutes or an hour or 2 hours, however long it takes, your brain just goes, all right, I think I got it, okay? For some people, it's a resounding, oh, I think I got it. But I don't know. I'm just kind of relating you with my experience. It was just like, all right, I got it, but I'm kind of tired, and I just want to get this done, okay? But now as a teacher, and I'm relearning this stuff, it's actually really exciting. So it is more like, oh, this is cool. You guys don't want to learn the proof of this, do you? All right, probably not. Okay, all right. We probably don't have time. So I guess logistically speaking, we don't have time to do proofs of this. But I'm going to give you more problems. Hopefully these problems are a little bit more fun. Let's do an example problem. They will give you conditions like this. What if they give you that f of 2 is equal to 3. They give you f prime of 2 is equal to 4. Then you got to find the inverse function of 3 and the derivative of the inverse function of 3 as well. So this is your question. These two conditions were given to you. That's it. There's no equations. There's nothing else. Can you solve for this? Okay, at your table now, try to solve this. And I would really recommend you go back to what I just went over with you. It will save you a lot of time. This is a logic problem. This is not purely math. This is a logical problem to produce. Good luck. Good luck. Please talk with your neighbors. This is not an isolated problem. Okay, so talk with your neighbors. Oh, okay. Yeah, please. So that key that will be for the honor students, right? And the honor students, theirs is almost identical, but at one point, questions might be different. Don't bring it. You have a good morning. I just started. I won't recommend anyone. I leave on podcasts. You? I leave on podcasts. Recently, so it's gonna be a better. I'm gonna keep up with the class. Did not think I would care. Yeah. What's wrong with you? Oh, totally. Are you here for a test or what? Yeah, I was wondering.
Because like they're because if these are inverse to each other, then these are gonna be like if the points are in.
You're supposed to.
So I was just like a cat fell.
Yeah. Just warning you now. This part is still. This part is still. Just grab a seat.
Like in my mind, I was thinking like the inverse would just be and why. But I guess you're saying that statement one is not
That's correct. That's correct.
But I think if we have to.
Nice. Yeah. Peter, there. Let me know when you're finished, and I'll give you the take-home portion. Anybody need more time? I need more time. Anybody want me to go over, or you guys still want to discuss? It looks like you still want to discuss about this. All right, so there's not a really strong, strict processional procedural way to do this. You guys want to see how I approach this problem? Okay. All right, let's see if you guys. So I will give you the answer straight out right now. This should be equal to 2. And this should be equal to 1 over 4. So let's break this down really quick, okay? Or break this down slowly, all right? I kept talking about BA and AB notation, okay? And then I've kind of memorized, let's say theoretically or hypothetically, I've memorized this to be the inverse function of f. If I take the derivative of b, it'd be 1 over just the derivative of just the original function of a, right? So I've kind of got that down. So it would be in my best interest to say, okay, f has a point 2, 3. Where did I get that point from, that coordinate from? Which statement?
F of 2 equals 3.
F of 2 equals 3 is basically saying a coordinate. That tells me I have a coordinate on this F. I don't know what the graph looks like. It could be like a swirl or spiral. Actually, it can't. I think that breaks the line test. Let's just say this is some kind of curve. I don't know what the equation is, but I at least know the coordinate is 2, 3. It's literally x. You put in x into this equation, it spits out a y value. So that's it, 2, 3. That is essentially like a b, a, right? To make it work with all this notation stuff up here. The inverse coordinate, can anybody give me the inverse coordinates for 2, 3? Yeah, I'm not trying to trick you. It's just 3, 2. You just flip them. That's it. And then a derivative the derivative, which was f of 2 here, the derivative at this point, or I'll just say the slope, derivative or slope, it's the same meaning. It has the same meaning. It's just derivative is a special slope at one point, not between 2 points. That was 4. And the slope or the derivative here, if you think about it, you got 2 ways to do this. You can plug it into this unique equation here, which I can do, right? But I'll just say this right now. If these are inverse coordinates, what do we know the slopes are going to be? Inverse, or it starts with an R. Reciprocal. So it's just 1 over 4. But I do want to show you like this kind of new methodology right here, up here, this kind of general equation up here. The way that your worksheet presents it is the inverse prime, the inverse function prime, or the derivative of that, at b, my b value is 2. So, sorry, I'm going to clarify. I'm going to add this 1 point down here. 3 comma 2 is like a comma b. If I'm taking f prime, or the inverse function, the derivative at b, the derivative of this, okay, the inverse function's derivative should be f prime of a. And then let's rewrite this one more time. I'm taking the inverse function's derivative at 2. I will have to take the derivative at my a value. What is my a value that I set? What is the a parameter that I set here? It's 3. Okay. So I need to find the derivative at 3, which I found out the derivative at 3. What, did I say that right? Whoops. Is that right? Did I mess something up here? Oh dear. Oops. Yeah. Hold on, let's go back here. Did I do that? Yeah, I did something wrong, didn't I? So that's probably why you guys were freaking out here. Okay, I did something wrong here. Shoot, all that work for a big mess up. I guess if I made an error. Okay, well, yeah, Sean. Let's see. Yeah, did I? I don't know. No, I think, yeah. Which one? Right here? Oh, did I? Yeah, huh? Let's see. Oh, okay. Because we are solving for this. I'm so sorry. Yeah, but it's still really confusing. Okay, so, Okay, so if I'm looking for this, I'm solving for 3 here, but it makes it really confusing because I put the B and the A over here, huh? I set that like that. Okay, so I guess that wasn't wise for me to assign that. Okay, let's reconfigure our thinking here because of my mistake, so I'm so sorry about that. If you take the inverse function's derivative at 0.3 here, you have to take the inverse coordinate. You have to take the derivative of the inverse coordinate. So the inverse coordinate was 2. And then the derivative at that point was 4. So hopefully that makes sense. So I do apologize about signing A and B and B and A. I don't think that was wise of me to do that. But I guess what this, let's make this a little bit more clear so you don't make a mistake like I did. If you take the inverse function derivative at your point, whatever that point is, I said it's 3, it's going to be 1 over the derivative of the inverse coordinate, which is 2. Does that make sense? Okay, so hopefully that makes a little bit more sense and will get you into less trouble. Or if anything, you can do just what I originally did here, which I think is the easiest thing for these logic problems. Just write it out. Your coordinate is this, the slope is this at this point, and then this here should just be the slope of the inverse coordinate, should just be the reciprocal. Okay, so I think it's a little bit easier for you guys. I think you guys got that a little bit faster. All right, do you guys want to do one more problem for inverse functions, or do you guys want me to move on to the next section? What do you guys think? How are you guys feeling about derivatives of inverse functions? Would you like practice with one more type of problem? All right, voted hands. Yeah, you guys want to do one? Okay, all right. You don't care either way. Okay, maybe that's a unanimous feeling from all of us. Okay, so that means I will put up a video for 5-2 then, because I think we have about 15 minutes. I won't even have time to get through everything I wanted to get through anyways. Okay. Here's one more example problem. If f of x is equal to x to the third minus 4 over x. Oh yeah, this might be really tough. Okay. If I have this, I want you to, let's see. And also one thing, so I think this is a problem that's actually in your worksheet. This is something that I added that's given. You can trust me that this is not in this problem, wherever it is in your worksheet. It makes it a lot easier if you know this step right here. The inverse function of 6 is equal to 2. And your task is to find the inverse function derivative of 6. All right, get to it. That is your problem here. This is going to be your problem here. Okay. Whiteboard problem, please. So go to the whiteboards, and you can stand there and ponder for a while too. You don't have to find out anything yet. You don't have to actually do anything yet. But stand up and try to figure this out. I always forget this one. I'm just writing some stuff that might help you, some little clues here. So this is additional stuff that might help you. Okay, so these are two things that we've learned today. This one is something that you might need to kind of see. You might need a different perspective for f of x. I don't know if anyone might see it, but do you have to find the inverse function for this? Do you actually have to find the inverse function of this guy? You do not. Okay, just letting you know. Don't get stuck on that. You, with the information that you're given, you actually do not need to find the inverse function. In fact, if you get a problem like this, that should give you a clue that you shouldn't have to. This is tough. This is really tough to find the inverse function of this guy. So publishers, when they write problems like this, at your level at least, okay, not to sound condescending, but where you are right now in your learning, they wouldn't expect you to figure this out by finding out the inverse function. But they would ask you to use logic for this. This is not easy. I don't think this is very easy. Number 16. Did you guys find it out?
Yes.
What do you guys think?
1/13.
That is correct. That is.
It's gonna be minus 1 here, and then once it comes out.
Stephanie, what did you get?
Oh, yeah, 113.
I'm just like writing, I'm just doing what I did up there onto my homework sheet.
Sure. Keep going.
I was totally confused.
With that problem.
Yeah, because it's
Yeah.
not working.
So for anybody that was working on the worksheet that encounters this problem, this piece was not given to you. So really make sure that you make a note of that. Where did you already?
No, I was trying to find it, and it frustrated me so much, because like that wasn't given. But then I watched the video, and then you gave it, so I was like, okay.
Oh, you did watch them. Wow.
I mean, I didn't watch all of them. I watched the last video, and I scrolled to the end.
But ahead of time though, that's a yeah, that's a good strategy. Skip to the ahead of time because I do talk a lot in between. But actually, okay. I guess we only have a few minutes to go through this. You guys should have gone 1/13, but how the heck did you do that? I do not know. I'll show you the way I kind of did it. I'm kind of happy that I did go over this in a previous video, but so right here, I know eventually. So I guess you can kind of go out of order, but the way I saw it was, all right, I have no idea what's going on, but I do know eventually I have to take the derivative of this guy. So I could do that at least. I had to rewrite this though. So anytime x is on the bottom of a fraction, rewrite it as 4, and then you can do it times x still. So it looks kind of more familiar. You can figure it out more horizontally, going from left to right, instead of having this top-down thing here. So it's going to be, and I know that the derivative of x to the 3 or x to the third power would be 3x squared. And if I look at it like this, 4 over x, that's the same thing as writing it as 4 times x to the power of -1. And I can take the derivative of that using the power rule. I just need to drag down this exponent to the front. So that will make minus 1 times 4x to the -2nd power now. I have to subtract 1 from that exponent. For most of you guys that did it in your head, this might look confusing because you don't write this out. You could have done it in your head to be plus 4x minus the 2nd power, okay? But I like to show where that came from. You had to take the exponent, put it in the front here, okay? And then you subtract 1 from this exponent. That's what happened here, okay? So that's ready to go, okay? Maybe you didn't do that first. It's fine if you didn't do that first. Then I said to myself, okay, can I take the inverse function of that? That looks really hard. That means I would have to I would have to make this y is equal to, so like x to the third power minus 4x, and I have to switch the x and the y and solve that. I think most of you guys got to that point. You're like, what is going on? This is hard, okay? Well, if you don't know and you're on the test, let's say the AP exam, okay, take a step back and be like, I don't know how to do that, but let's say f inverse, a coordinate would be 6, 2. That doesn't look so bad, right? And then they're asking me to find the slope or the derivative at x equals 6, right? Okay. And if I want, I know it's really confusing, but you can't look at this as being a. Hopefully I don't mess this up if I try this, but and I know I got two options here, but hey, I did kind of learn that if you plug in b, right, if you're looking for the f inverse of the derivative of the inverse function of b, which in this case would be my 6, I would have to take the derivative of what my a is. And my a, I do have a value. It's just the other part of the coordinate. So I guess I didn't mention that last time when I explained this. I'm so sorry about that. But it is just 2. I don't think that's too bad. So 1 over the derivative of 2. How would I find the derivative of 2, though, at this point? How would I find the derivative of 2? Any guesses or any ideas as how do I find? I don't know if this is exactly the way you guys did this then. Maybe I am doing this wrong. Yeah, you just plug in 2 into the actual derivative equation. You know, I was trying to set myself up for success. So it would be 1 over 3 times 2 squared plus 4 times 2 to the negative second power. It looks weird, but what that will actually look like, let's simplify this. This is going to be 3 times 2 squared. That's 3 times 4. Plus, if you don't know what to do with that negative exponent, you basically put this whole thing into the denominator of a fraction. That'll be 2 squared now. That exponent now becomes positive, right? That'd be 1 over 12 plus 4 divided by 4. And that'd be 1 over 12 plus 1. I know in your work, you might have skipped a lot of steps. I'm just trying my best to write as many as 1. Oh, look, it's catching up now. 1 over 12 plus 1. And that should ultimately be 1 over 13. Okay? Any questions so far? This is definitely something I'm going to ask you to go back and restudy your notes about what happened. Okay? It was a flash blur of things that felt good, it felt weird, and I don't know what's going on. Okay? A weird childhood experience on a piece of paper. So go back and restudy what happened. Okay? All right, guys, that's it. So good luck. I'm going to post up 2 videos, not from me explaining 5.1. All right? And then 5.2, I think I will have to make a video for that. Okay? So I'm going to post that up as soon as possible. Guys, have a good day, guys.
There you go, sweet.
And I will give you the take-home portion. Sorry if you're waiting for me. Hey guys. You great? Oh, just put breakfast.
Okay.
What's going on? I'll leave it on this here, and you just be here. Yeah, I do. This is a teacher edition, so you can wait. I think it's just for you. Here you go. Regardless. You want the solution manual too?
Oh, that's okay.
Okay. Hey Stephanie, on your way out, can you? No, actually, no.
Can I do what?
I was gonna ask you to turn on the lights. I'm like, I don't want the lights. But I'm gonna open up the blind. Les, do you want the lights on for a little bit? Yeah. Yes, Stephanie.
I asked, remember when I asked you about recommendations? I
Yeah.
put your information in, I don't know if it's.
Oh, Oh, is there a deadline coming up, or I didn't check?
It's December 15th, finished. So it's,
Okay, it's coming up very close. Okay, so I gotta pencil you in. Thanks for letting me know.
cause
Okay.
like, I'll check to still make sure that it's right in there,
Yeah.
but I want to.
I thought I like missed the deadline or something.
No.
Yeah. Sorry,
I'm just like
just be
reminding you because it's like getting closer.
Yeah,
And I'm like,
just be cognizant that I'm very yeah. I'm just like quite fast. Okay. Number 15. That's something I gotta start writing. They literally. Okay. All right, Stephen. All right.
Do I need to make a new column for test corrections? It looks like test corrections are row 3.
I know it's really confusing, but let's see. What's the column say?
You have number 2.
So, okay, this is really confusing the way.
Probably like do like the next one.
So yeah, so like test corrections for the month 1 exam. Oh, yeah, no worries. All right, see Sarah. Oh yeah, because they just they got their exam today, so I'm just gonna get corrections about that. That's fine.
Oh.
Shoot, hold on, I gotta stop the video. This video's still running. Sorry, and then I'll come back and create that.
I was like.
It's kind of a sad day, sad looking day.
Well, it's supposed to rain at 3.
Oh, that's when I was gonna go surf too, and I know it's like it's supposed to get really.
Little adventurous.
Yeah, I heard it's gonna be big. I'm scared, so I'm gonna go to
Well,
like
they said there is a blizzard coming into the U.S. And it's just gonna be cold. And I was like, is that when it's like super cold in the morning?
Yeah.
It just gets cold, like
You
San
get it.
Francisco cold.
Yes, it does. I'm glad you said that. It totally does. Yeah.
And I read it, like, oh yeah, there's a blizzard coming. I'm like, oh.
You're a wizard, Harry. No, it's blizzard. Okay. So I think I stopped the video. Let's go back to you. No worries. Okay, so we'll add this here. Add. Okay. Test corrections for month 3 exam. I don't know how Dr. Green would that
You mix Dr. and Mr. Green.
Yeah. I don't know.